Okay, 6.5 day 3, we're going to do the last section of chapter 6. We're going to do some more properties. So we're going to go ahead and simplify. If I do the log base 5 of 5 squared, what do you get? Well, it's the log base 5 of 25. The log base 5 of 25 is 2 because 5 to the second is 2. So the log base 5 of 5 to the second is 2. So if the log base 5 of 5 is saying, what's the exponent? You can see the exponent if the base is 5. So they're giving you the answer. Okay, so if we look at B, log base 3 of 3 to the n, what do you think the answer is, even though there's no numbers there? Yep, this one was 2. So this one is saying, what's the exponent when the base is 3? Well, the exponent is n because I can see it right there. So log base 3 of 3 to the n is just n, because the log is asking what's the exponent when the base is 3. So for C, the log of 10 to the 7th. Okay, well, this is common log, so the base is 10, so it's saying what's the log? If the base is 10, what's the exponent? Well, the exponent is 7. I see it. It's right there. Okay, what about the ln of e to the 6th? Okay, 6. It's saying what is the exponent when the base is e? Well, I can see it's e to the 6th, so the exponent is 6. Okay, so log and exponents, they kind of cancel each other out. So this one we're not going to do in our head, but we're just going to guess the answer. If I do 5 to the log base 5 of 2, what do you think you end up with? And you just end up with 2, because the exponent and the logarithmic part, they just kind of cancel each other out. So if I do 4 to the log base 4 of 2x, I get the 2x. Okay, if I do e to the ln 5, e and ln are inverses of each other, so I end up with 5. And 10 to the log of 2x plus 1, the exponent and the log kind of cancel each other out, and we're just left with the 2x plus 1. So if you see something like that, they look very complicated, but then you think, oh, they kind of cancel each other out, so I can get the answer really quickly. Okay, we're going to learn one last formula. It's called the change of base formula. Okay, now most of your calculators only have a common log button, and they have an ln button. And that's all they have. Okay, some of your calculators have other bases. Okay, some do not, but this is probably how your calculator is calculating it. Okay, so it says let a and b be positive. Remember, we're positive because we can only log positives. So when they say that, they're just saying make sure you're only logging legal numbers like positives. Okay, we're going to use the change of base formula to approximate the logarithms. So if I want the log base b of a, and my calculator does not have the log base b of whatever I want, the formula to find it is log a divided by log b, or we could do ln a divided by ln b, or we could do any other log version of a over b, as long as they have the same base. Okay, I'm going to show you why this is true on the side, but you do not need to know this, but some people like to know. Okay, so I'm going to say the log base b of a is what we're trying to solve. I want to see what it equals to, so I'm going to go ahead and call it x. Okay, I'm going to rewrite this in exponential form because that's just what we do a lot of the time. So what am I going to have? I'm going to have b to the x equals a. Okay, now if I want to rewrite this in terms of common log, I'm going to do the log of both sides, even though you don't know why I'm doing this yet. This is what I'm going to do. As long as we do it to both sides, it's totally legal. Okay, so now I'm going to log this side. I don't know what either of these answers are. Okay, now I'm going to try to solve for x. The power property for log properties means I can bring the x down. So let me bring down the x. So I have x times the log of b equals the log of a. And then if I want to solve for x, I divide both sides by log of b. So then I get x equals log a over log b. Which is how they're figuring out that the log base b of a is log a over log b. I will never ask you to prove that, but I'm showing it to you so you know that the formula is not totally made up. Okay, so let's try this, and this is normally when you want a decimal approximation. So if I want to do the log base 2 of 32, to be fair, I already know the answer. The answer is 5, because 2 to the 5th is 32. We're going to do this one to make sure that it actually works. Okay, I'm going to rewrite it as either this ratio or this ratio. It does not matter which one you pick as long as you're consistent. Which one should I do? I'll do the first one for the first one. So the log, it's going to be the common log of 32 divided by the common log of the base, so log of 2. Okay, and this is just because this button is easier to do on my calculator. Okay, now I'm going to put it in my calculator and I'm going to get a decimal. Okay, so you got to find your log button. I'm going to do log of 32, and I'm going to divide it by the log of 2. Okay, when I put it in my calculator, I get 5. which makes sense because in my head, I knew that the answer was 5 because 2 to the 5th is 32. Okay, I'm going to try it on B. Now for B, the log base 2 of 9, I don't know what the log base 2 of 9 is. I know the log base 2 of 8 is 3, but I do not know the log base 2 of 9. So let's use the formula. Okay, now it doesn't matter if I use common log or ln. I'm going to use log for the first two, and then I'll switch on the other one. It might just be whichever one you can find on your calculator easier. Okay, so on the top, I do the log of 9 divided by the log of 2. And then I put this in my calculator to get a decimal approximation of the answer. Hold on while I put it in my calculator. Okay, so I got about 3.1699. It didn't say how many decimals, so include a few, and I'm not going to worry about it. This seems reasonable because log base 2 of 8 is 3, so the log base 2 of 9 should be a little higher. So 2 to the 3.1699 should be about 9, but it's an approximation. Okay, I'm going to do the next two the same. Instead of using common log, I'm going to use ln for no particular reason because they work equally good and will give me the same answer. Okay, so I'm going to do the ln of 245 divided by the ln of the base. If you like common log, keep using common log and then check your answer with me. We're going to get the same answer because this really works with any base. It's just a matter of which button is easier for you to get to on your calculator. Okay, hold on while I put it in my calculator. ln of 245 divided by the ln of 9. Okay, I got 2.5037. It didn't say how many decimals, so just include a few and we'll be okay. That's saying 9 to the 2.5037 is about 245. Okay, last one. Log base 12 of 3. Don't know the answer. I'm going to use I'll use natural log again. Natural log of 3 divided by the natural log of the base. Okay, and again, you can use common log. Doesn't make a difference. We should get the exact same answer either way. And I'm putting it in my calculator while you are here. Okay, I got let's keep a few decimals, 0.4421. So that's saying 12 to the 0.4421 equals 3, which kind of makes sense because it's getting smaller, so the exponent is small. I'm some kind of root.